Hi there. So part one of the video went over this page of multiplying and dividing powers. So now if I go to page 2, we shall do some examples. So when you get examples like this, they're very big and they can be very confusing. So the idea is to break them up into like bases. So remember, anytime you're dealing with exponents, we have a base to a certain exponent. And the b we call the base, and the n we call the exponent. And you can only combine bases combine exponents with the same base. Only combine exponents with the same base. So we'll do this through a few examples. And I think these examples, they can be confusing, but if we break them up into simpler parts, hopefully it will help. So if we look here, we can see right away there are some -3's. So if I group them together, we have a -3 to the power 11, and we have a -3 to the power 5. And then we also have two y's. So we have a y to the power 6 and just a y in brackets. So which one do you want to look at first? Now this one, let me label this. This is multiplying, right? So this is multiplying. And these two here, we're dividing. So if you remember from the previous video, maybe I'll write this on the side. So when you multiply exponents with the same base, exponents with the same base. You add the exponents. So in general, if we had base to some, let's say number 2 times base to some number 3, that would be equal to the base to the power 2 plus 3. Well, 2 plus 3 we know is 5, so that would be the base to the power 5. Now when we're dividing, it's not exponents, it's powers. And we're just I was like, yeah, so maybe instead of using the word exponents, I'll use the word powers. That's more of the math language. So dividing powers with the same base. And this is repeated later on this handout, but I thought it's important to write it out. So whenever you write something out, you have a tendency of remembering it better. So dividing powers with the same base. We subtract the exponents. So for example, I'm just going to move this up a little bit. If we have, let's say, b to the power 3 over b to the power 2, that means you're dividing. Then you would take the base, and they have the same base, which is b, so imaginary b. Then you would say the top exponent, the 3, minus the bottom one, which would be equal to b to the power 1. So anything to the exponent 1 is, you can write just as b, because it's like b, just b. You're not multiplying it to itself at all. So now here, if we look at this example, you look at the way the -3's are written, and you can see that's dividing. So what we're going to do is rewrite this, applying this division rule. So we would have -3, and the top exponent is 11, the bottom exponent is 5, so we could write 11 subtract 5. So then we know 11 subtract 5 is 6. So that would be -3 to the power 6. And we'll simplify that, or we'll just leave that for now. I think we'll just leave it without solving. So it says here, do not evaluate. Now here, y's, written like this, they're multiplying. So we're going to apply this rule. We're going to add the exponents. So this would be equal to y to the power 6. What's the exponent if you don't see one? That's right, it's 1. So 6 plus 1. So that would be equivalent to y to the power 7. Okay. And if you have questions about any of these, please let me know and I can help. All right. I'm going to leave these rules written here as we look at this one. So again, lots of mixed up bases, and so we want to combine the like bases, the bases that are the same. So if I look here, I've got an A here, an A here, and an A here. So I'm going to combine those ones together first. So we have A to the power -2, A to the power 7, over A to the power 4. And then we look, we've got this -1, -1, and -1. And then we're going to write that next to it. So we have, let me just block that off so we don't confuse it. We have -1.5 to the power 4. Again, no exponent here, so what's the exponent? That's right, it's 1. So right away I can say that's 4 plus 1. Do I want to write that out, simplify it a bit, or should I? I think I'll write it all out so we don't miss any steps. To the power 1, and that's all over. So those are -1.5 to the power -3. Now we're going to simplify. Simplify, do not evaluate. So up here, because these two a's in the numerator are being multiplied, we're going to add those exponents. So we're going to have a -2 plus 7. And that's divided by the same base to the power 4. So when you're dividing, you subtract the exponent that's in the denominator. So subtract 4. And now that's going to be multiplied by, again, multiplied in the numerator. So we're going to have -1.5, 4 plus 1, and then we're going to subtract a negative number. So it's in the denominator, so we're going to apply the dividing rule by subtracting. Subtract -3. And if you're uncomfortable with doing all of this in your head, the addition, subtraction, and the exponent, put it in your calculator. Better to be safe than sorry. So -2 plus 7 is 5. Subtract 4 is 1. So we're going to have a to the power 1. Now, what happens when we have a negative and a negative? A negative and a negative becomes a positive. So then we're going to have 4 plus 1 plus 3, which is 8. So then we have -1.5 to the power 8. And you can leave it like this and you would get full marks. But just normally in math, we like to see the number first and the variable next. So I'll just rewrite it like that. And again, we're not evaluating it at this point. So we'll have negative 1.5 to the power 8 times a. And if the exponent's 1, you don't need to write the exponent. I wouldn't deduct if you left it. So either way is fine. And what is important is that the negative 1, negative 1.5 is always in brackets. So leave it in brackets. One more example here. So what I'm going to do, and I recommend you do, is pause the video and group these together. Group the like terms, like I grouped the like terms up in this previous example. So pause the video until you've done it. So if you're watching it in class, pause it for like 3-4 minutes. All right, so hopefully you took the time and you paused and grouped it together yourself. So you can see here, the x term doesn't have an x in the denominator, so I just left it on its own. And similarly, the z term the z term didn't have a value with the base z in the numerator, so I just left it like this. So now if we look here, 2 to the power 10 over 2 to the power 5, what do? That's right, we subtract the exponent. So we have 10 minus 5. X to the power 3 stays like this. Here, 6 is in the numerator, 1 is in the denominator. So we can subtract the exponent in the denominator from the one in the numerator. So x, 6 minus 1, and that's going to be all over z to the power 2. So right now, we're almost simplified. So we'll do the arithmetic in the exponents. So we have 2 to the power 5 times x cubed times y to the power 5 all over z squared. So we would say this is simplified. And if you were actually to evaluate it, you would put 2 to the power 5 in your calculator and see that it's 32. And finally, just to summarize the last two videos, if 2 or more powers have the same base, a, then the product rule, hopefully you know it now, will be adding the exponents. So a, m plus n. And if in the quotient rule, if you're dividing 2 powers with the same base, you would subtract the exponent in the denominator from the exponent in the numerator. I hope you enjoyed the video, and I will see you later. Bye-bye.